Hello, everyone, and welcome to some 95 review. We're going to go over some homework questions, review some concepts. Apologies in advance. I'm not talking normally yet. I had some surgery that I'm still recovering from. So, we're going to start with number 2, representing ratios in different ways. So this one wants us to represent the following scenario as ratios in the indicated ways. So, there's a lot of different ways we're going to be doing the same thing. And then we need to determine if the comparison is part to part for the ratio or part to whole. So remember, part to part is when you're, comparing part of something to part of something, whereas part to whole would be part out of everything. So an example of part to part would be, I drive 2 miles for every 1 mile that I walk. Whereas part to whole would be I drive 2 miles out of 3 miles that I go. It was like 2 compared to 1 or 2 out of 3 are the same mathematical values, but one's part to part, one's part to whole. So in this situation, we have Sharon, and she's practicing some free throw shots. She made 18 shots for every 3 that she missed. So we're going to look at, in this first area here, ratio of shots made to shots missed. So the unsimplified is given here. 18 made, 3 missed. That's exactly what we put here. 18 made. Whoa. And it wants us to do as a fraction. 18 made out of 3 missed. We got that right there. But that's not simplified, of course. That's just the raw data. Made is on the top. Missed is on the bottom. Great. Now we can simplify that. We can divide the top and the bottom both by 3. 18 divided by 3 is 6. 3 divided by 3 is 1. Again, what we're really doing when we're reducing here, we have 18 divided by 3. We can divide the top and the bottom by 3. That's their common factor. 18 divided by 3 is 6. 3 divided by 3 is 1. 6 any number divided by 1 is just itself. Okay, so that should be good to go. And now we can also look at the second column, shots missed to shots made. So remember, whatever is first is always going to be on the top. So this time it's 3 missed and 18 made. Same data, but here it's made to missed, and this is missed to made. So it's going to be the reciprocal for the fractions. Now again, we divide the top and the bottom by 3. You get a simplified fraction of 1/6. We can also represent ratios, not always as fractions, and usually fractions, in my experience, are like part to whole. Part to part, I think ratio, the colon form, is more common for that, but here it's just having you practice do both. So shots made to shots missed, unsimplified, made is going to be 18, missed is going to be 3. And again, we simplify that in the same way. 18 to 3 is the same as 6 to 1. Whoa, 6 to 1. Just like we wrote down in our calculations right here. 18 to 3 is the same as 6 to 1. And then vice versa over here. We can put this as 3 and 18 because it just matters which one's first. Okay. And then 1 to 6 like so. So are these part to part or part to whole? Well, the key is looking at this. Is she making 18 shots out of 3 total? No. 18 are the shots she made. 3 of the shots she missed. There's 21 total shots here. The 21 is the whole, and the 21 is not being mentioned anywhere here. So there's no whole. This is going to be part to part. Let's check. Great. Your math professor got the question right. That's always a good sign. Moving on to the next one. This next one's going to be good practice for statistics. So in statistics, right, a lot of times when we deal with qualitative or categorical data, we look at proportions. So if we want a sample proportion, that's going to be a proportion. So we're getting practice with proportions right here. Okay, so for example, maybe we found out that there was 5 respondents who said yes to some question and 10 total respondents. Is that the same proportion as some number over 30? Yeah, and we can find that number z. That's what we're going to do over here. And making sure, please always make sure to read these instructions. So you're not just putting the answer for z. Look at exactly how it wants you to phrase your answer here. So 5 out of 10 is equal to z over 30. Now, a lot of people are familiar with the cross multiplication method, which is fine. Really what we're doing here is we're multiplying both sides of this equation by the least common denominator. But the cross multiplication method works. If you do that, we get 10 times z is going to be 10z. And that's going to equal 5 times 30. 5 times 30 is 150. Now I can divide both sides by 10 to get the z by itself. Left-hand side, the 10's cancel. The right-hand side, 150 divided by 10 is just 15. And we'll get z is 15. That's what we're going to write as our answer because that's how it specifies it wants the answer. Just like so. And hopefully we can check our answer, right? 5 divided by 10, what is that? Is that the same as 15 divided by 30? Ah, great. So if we took two different samples, say we're curious about, in statistics, how many people support some kind of measure or some candidate, and we took one of sample size 10, and 5 people supported that candidate, and another of sample size 30 is the total, and found that 15 supported that candidate, that'd be the same sample proportion. Okay, that'd be that same p hat, remember. All right, we can do these. I'll do one more. Let's do this third one on the bottom. We don't need to do all of them. 5 over t is 25 over 65. This one's a little different. Let's say we took two samples, and the first one was a sample size of 65, and we forgot maybe the sample size of the other one. And in the first one, 25 supported that candidate, and the second one, 5 supported that candidate, and we remembered that it was the same proportion. Well, we could use that if we remembered it was the same proportion. We could use that to solve for that sample size. Proportion is just part divided by whole in many cases. And we can think about these proportions in that way. We can still cross multiply here. And if we do that, we get 5 times 65. 325 maybe is equal to 25 times t. We'll check our answer to see if I made a mistake or not. And then we divide both sides by 25 so that we can get the t by itself. The left-hand side, divide that out. I believe that's 13. The right-hand side is going to cancel and just give us that t is equal to 13. And we can check our answer. Okay? t equals 13. Is 5 divided by 13? Is that number the same as 25 over 65? Looks to be the same. Great. There we go. Check our answers. We formatted it correctly. We got 2 out of 4 because we didn't do 2 of the problems, but that's the idea here. So when you're thinking of proportions, remember that it definitely ties into statistics with sample proportions, and we'll be doing a lot with sample proportions in this whole class. All right, next up, let's look at number 7, setting up an application. So in Atlanta, Georgia, the tax on a property assessed, so this is talking about property tax for very expensive properties, or at least compared to mine, assessed at $820,000 is $10,000 and 660. Which of the following proportions could you use to find the tax on the property assessed at $900,000? So there's a lot of different ways that you can set this up. The idea is to set these proportions equal to each other. So one of the ways that you could do this was tax over value equals tax over value. Let's say tax 1, value 1, tax 2, value 2. You could flip these upside down. Now it would work too. You can do tax 1 over tax 2 equals value 1 over value 2. So proportions, there's so many different ways to set them up. There are 3 ways I can see to do this one, 4 really. And the book, this homework question only is really having one of the form. Oh, select all the proportions that could work. Okay, so good thing so let's write this down. So let's look at them. So what's the tax of the first property? Find that tax out of that first property, 10,660. Divide by the value of the first property, 820K. That's equal to the tax of the second one, which we don't know, divided by the value of the second one, 900,000. So that's one option. Is that any of our choices? 10,000 with 820. It's similar to this one. Is it the same? 900K divided by X. That's the reciprocal. 820K divided by 10. That's the reciprocal. So since they're both upside down, it's the same. If you only switched one of them, it wouldn't be the same. And you can check that they're the same by cross multiplying. If you cross multiply our guy and you cross multiply this one, you're going to get the same thing. Again, I said that as long as you flip both of them, it's still the same. Right, okay. Check that by cross multiplying and see that it is indeed the same. All of these should give you the same exact equation when you cross multiply. And in fact, that's maybe even an easier way of verifying this problem. If we cross multiply, right, we get 10,660 times 900K equals 820K times X. So any one that has 900K times 10,660, oh, this one also, when you cross multiply, has the same equation. 900K times 10,660. Oh, this has the same one. 900K times, oh, this one's wrong. When you cross multiply this fourth one, you don't get the same thing. So that's another way of approaching this. Is instead of writing every single possibility, because there's a lot, find one possibility, cross multiply, and notice that, okay, if we set our proportions up correctly, you're always going to get the same equation once you cross multiply. That can save you a little bit of time. All right, let's look at number 11, a different kind of application. So for these ones, whenever you see the word is, think equals. When you see the word of, think multiplication. So when it says 213.5, well, that's not the number. When it says 213.5 is, we write is. Is equals. Is what percent, and again, if you want to write what, you can think of that as a variable. So is what percent of is multiplication, 350. So just converting each word to math. Is what percent of 350? And now we just solve for X. All right. The percent sign can make things a little bit confusing. But let's solve for X by dividing both sides by 350. Okay, when we do that, it cancels on the right-hand side, and we get X percent is 213.5 divided by 350, which we can calculate that. 213.5 divided by 350. That's 0.61. So now what percent is 0.61? Remember, percent It's just that number divided by 100. X% is the same as X divided by 100. Just like 3% is 3 divided by 100. It's the same idea. Just instead of a 3, we have X. 5% is 5 out of 100. Percent per 100. So X% is equal to 0.61. We multiply both sides of this equation by 100 to solve for X. Cancellation on the left-hand side. We get X is 61. Another way of saying that is 213.5 is 61% of 350. We can check our answer another way. 61% of 350. Hey, there it is, 213.5. 61, we already have a percent right there. We're good to go. Last one I want to look at is some simplification with negatives and fractions. Let's remember our orders of operations. So -3 times -4 halves divided by 2. And again, we can think of PEMDAS. And remember that when we do PEMDAS, it's really parentheses first, and then exponentials. Multiplication and division can be in the same chunk. Same with addition and subtraction. So let's simplify what's inside the parentheses first. -3, that's already simplified. What's 4 divided by 2? That's just 2. All right, so that was our parentheses. Everything inside parentheses is simple now. Exponentials, there's no exponents, no exponents. Now we can do multiplication and division in any order. Usually we do it left to right. Okay, but you don't have to. And in fact, I could show you that either order is going to work. But let's just do left to right. That's a little easier. In this first one, we have -3 times -2. The opposite of 3 times the opposite of 2. Opposite of an opposite cancels out. All right, if you turn backwards and then turn backwards again, you're back to frontwards. So this becomes a positive number, and then 3 times 2 is 6. Divided by 2, okay, is 3. That should be our final answer. Great, it is. And that's basically it for this video. Let me know if you have any questions, and good luck. Remember that if you want to review any of these concepts, there's a full list of lecture videos and notes. This is just kind of phrased to be like a little review if you kind of know some of this but want to brush up on some topics. That's what these videos are for. But if you want full notes, full review, full like traditional lecture style, there are those videos in the same module. So let me know if you have any questions, and have a good one.